It's about to start, we'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is this thing. We are in the middle of making up this component that will allow us to draw waveforms in our JS effects, in our real-time audio processors for Reaper. And this has been a much more elaborate process than I was expecting it to be. We are working on this idea that is kind of elaborate, kind of weird. And the idea is that we will communicate the samples that are coming in, the audio that is coming in, from the audio thread that has access to the samples to the user interface thread that will actually draw the component. We'll do that communication using a circular buffer. The circular buffer will be written to by the audio thread and will be read by the drawing thread. That much we already implemented. Then we are going to read this circular buffer, the samples from this circular buffer, and we are going to draw the waveform. We will do that directly, but we'll not be drawing into the screen. No, because that would be too easy. No, we are drawing into an off-screen canvas. And the reason we do that is actually twofold. The first is an off-screen canvas, as far as I can tell, persists over frames of drawing, while the screen itself, the screen you draw to, it's shown to the user and discarded. You don't have a way of keeping that around for future frames. So that's reason number one. Reason number two is that we will need to scroll this picture. Effectively, this off-screen canvas behaves like a picture. We'll need to scroll it around the screen to make the waveform move. And we'll need to be smart about how we do that drawing and that scrolling. We'll need to slice things and draw things. It will be complicated. And even the scrolling itself will be kind of interesting because we currently, or up to this point, in all other attempts of this component, we were just relying on the timing of the drawing itself. So the drawing happens every frame, so 30 times a second or 60 times a second. We were relying on that 30 or 60 to do the scrolling. But in fact, some frames may be dropped. There is no guarantee of timing in terms of when that function will be called. So the visual effect of that is something that I think I can show here, for instance, in real image. Again, every time I bring this up, I have to say you may not be able to see this on the stream because the stream is at 25 frames per second. I'm looking at something that is 60 frames per second. My screen is running at that frame rate. So you may not be able to see this, but of course, if you load real image on a track, you will be able to see it, and I can see it, that it is smoothly scrolling and then it kind of jumps around. It's not perfect. It's not bad. But I think that I think that the issue here with this guy is that it is relying on the timing of the drawing function. I think so. I don't know how this was implemented, but I do see this issue here. I saw this issue in other plugins, like the compressor in Logic also has this issue. And I think that there is a way of smoothly scrolling based on time instead of based on the frame rate. And I think that that will be smoother. So looking at this, for instance, I also see it jumping around. So maybe there is no way of getting it right. Maybe this is just the nature of the game. I don't really think I have an example of a plugin where the scrolling is smooth like I'm mentioning, but we'll give it a try. Maybe we'll be able to do it. Or worst case scenario, it will look like this, which is not bad either. Now, what you do see on the screen right now is something else entirely. What you're seeing is a plot of the circular buffer used to communicate between the audio and the user interface threads. And this is a short buffer, relatively short anyway. It's not like 5 samples, but it's a relatively short buffer. And that buffer is just pessimistically expecting that there will be like 10 frames that you dropped. So the drawing function will only be called every 10 frames. And we are storing 10 frames worth of samples so that if the user interface thread is not refreshing as often as it should, at least we'll be able to accumulate and buffer things for when it gets back up. That's the intent anyway, we'll see. So let's go over the code that does all this I explained, because I need to get into the headspace again, and I think that you need to. So I have here this notion of refresh rate, which is a constant that is necessary for computing the size of the circular buffer. As I mentioned, it is 10 frames worth of I guess, buffering in case the UI thread isn't refreshing as often as it should. I'm putting 10 frames there. Maybe I could have a constant for this as well, so you will have control over this outside in case you know that you need more buffers. You need a bigger buffer. So let's think about how we want to call this. It will be samples, and it will be frames size, or maybe size in frames, something like that. So we have this constant and we have this other constant here. If you want, you can change the constants before you allocate the waveform components. So you can change the allocation if you change the constants. So I guess if constants change, are they really constants? I guess they are variables. But anyway, there are settings that you can use as the programmer. Before you allocate the waveform data structure, you can change the size of that buffer. And I don't think that there is a way for me to extract this whole formula into a constant, because this formula depends on the sample rate, which may not be available at the time that you are initializing stuff. I don't think that the sample rate is available on the init block, but I forget because these details are hazy. In any case, and then, so these are constants that you are sort of expected to tweak as advanced parameters for the waveform. For allocating the waveform. What if I just took them as arguments here? No, I don't expect the people to change these numbers. I guess also if you had to allocate multiple waveforms, you would have to remember which values you passed, so it makes sense to do it this way. And this refresh rate is referring to this. I am updating the refresh rate. By default, it is 30 times a second. I am updating it to 60 times a second, which does make everything, it makes everything look better. It does make everything look smoother. So then we have the data structure itself. The waveform data structure currently only has this circular buffer, and the circular buffer contains its own write head, but it does not contain a separate read head. So from the perspective of a circular buffer, you are only supposed to access samples based on an offset computed based on the write head. But we will need a read head that is independent of the write head, because we are playing catch here. There is the write head, who is in the circular buffer, so it's writing samples as they come in, and the read head is in a different thread, and it will be catching up to the write head. So that's why I have a separate data structure field for the read index. In fact, that reminds me that there is something I want to change about the way that the circular buffer works. So we'll take a detour, because I'm not too happy about the way that the circular buffer works in one capacity. So let's go there and I will reason about this and explain what the issue is, and we can fix it, hopefully. And I don't think that this is going to affect much in the rest of the library. I really hope. So that's the first thing to check. How often is the circular buffer used elsewhere in the library? So all of this is the definition and tests of the circular buffer. And then the waveform display is the only client of the circular buffer so far. Great, because that means I can change this without affecting much. So let's go and explain what the issue even is. Right now, the write head, and this is something we figured out together again on the last stream about this. The write head sits in the place where we last wrote to. Let me show you what I mean. What we do is we update the write index right here on this line. So we update the write index and then we write to that location, which means that if you just at any point look at the write index, it will be pointing at the place where we last wrote something. What I don't like about this is that in a typical use, the thing that you want to do is you want to read from the circular buffer first, and then you want to write to the circular buffer. Why? Well, first of all, it makes more sense to read than write, because you want to read the previous values. Otherwise, you would be sort of misusing the circular buffer. One item in the circular buffer you're sort of discarding because you're writing on top of it before you even read anything out of the circular buffer. So, and I guess there is a second reason that has to do with how the offset works. But I'll get to that in a moment. So let's talk about what I want to change. Right now, the write index is pointing at the place where the latest value has been written. I want to change that so the write index at any given point is pointing at the next place that is available in the circular buffer. Right? And that will open up this one item slot, but it will also make the offset make more sense. If you are in this spirit of reading first then writing, an offset of -1 will give you the previous sample, and that makes more sense. So let's reason about what we need to change. So first of all, here, when we are initializing a circular buffer, what is the place that we are about to write to? It's index 0. This makes sense. Then we get a hold of the write index and we do the circular counting. I guess what I want is to invert these two lines. So now we are going to write a value to that location, then we are going to update it. And only then we are going to write that to the data structure. So this is a local variable, which means that from the perspective of someone watching the circular buffer working from the outside, you can pretend that to some extent the updates are atomic, because the write index is the place you are about to write to. You should not be trying to read from there, because essentially that's junk at this point. It's not really junk, it's just an old sample, but still, you shouldn't probably be looking at an offset that is minus the size of the circular buffer, because that may be in a weird state. So you may want to allocate one extra item there. But in any case, it will be sort of atomic, because you are writing the new index into the data structure after the new data is already there. And that's exactly what we want. And that's all we need, actually. So that's sort of cool. Is there anything else that I want to change about this? I don't think so. Right, but we do need to update the tests because the tests are not going to be working, right? I just changed the meaning of offsets and everything, so everything will be off by 1. Let's load the tests and see that the circular buffer is failing. So now let's update the tests for this to make sense. So the index 0 is not something that the offset 0, not the index. The offset 0 is not really something I should be looking at. Doesn't make a lot of sense to be looking at this. So instead, I will be looking at index -1, -2, and -3. Now, I said that it doesn't really make a lot of sense to be looking at the negative index that is the same size as the circular buffer itself, because it could be in a weird state. But that is only true if you are accessing the circular buffer concurrently on the audio thread as well as on the UI thread. As long as you are not doing that, it's okay. It's safe to go to this location. And then here we also need to just add 1 to these indices. And it's never the case that I want to look at the circular buffer at position 0 or positive numbers. It's only offsets that are negative, just like that. And I think that this will make tests pass. And they are passing, great. So that will come in handy over here in the waveform display. So bear that in mind. It will all make sense in a moment, hopefully. So I have here the function that allocates a waveform display, the component. It will store, interesting. It says memory new 1, but it seems like I need 2 slots, don't I? So 1 for the samples and 1 for the read index. Samples being a circular buffer. The size of this circular buffer is the size in frames times the frame rate divided by the refresh rate. I guess that makes sense. So if I have 10 frames at a sample rate of 48,000 divided by a refresh rate of 60, I get 800 samples. That sounds about right. Oh, it was supposed to be 48,000. So if my sampling rate is 48,000 and I have 60 frames per second, I have 800 samples per frame. That makes sense. And then just multiply that by 10, you get this number, which is the number of samples we will have in the circular buffer. All right, and then the read index. Does it make sense to start at 0? I think so. Yeah, you don't want to start with a negative number here, I don't think, but we'll see how it's actually used over there. Then to push a sample into the waveform display is really simple. You just get a hold of the sample and or you get a hold of the circular buffer, the samples circular buffer, and you push using the circular buffer method. Okay, so far so good. Then to draw, I will get a hold of a bunch of things from the samples, which again is the circular buffer. I will get a hold of the circular buffer itself, the length of the circular buffer, as well as the write index in the circular buffer. Because remember, I will need to update the read index to catch up to the write index. So I better have that write index, and I do. Then I will have the read index, which is part of my waveform data structure. And then I will do the catch-up. This is a part where I take the read index and I go up to the write index. And now this comparison makes more sense. When I first wrote it, the write index had valid data in there because the write index was pointing at the place where we last wrote. Now this comparison makes a lot more sense because if the read index has caught up to the write index, it needs to stop. And that's what happens here. Great. Then I take this read index and I update it just like that. So it does make sense to start at 0 because I will be updating this. It does make sense to start with 0 because suppose that we just started and then there are no samples in the circular buffer, this will not run because 0 is equal to 0. The right index also starts at 0. So all of this checks out. Then I have my read index, and the logic for I'm wondering where the logic for drawing should appear. There are two options. It can be before or after updating the read index. I think it needs to appear before, because we do want to read sample 0. So to do actual drawing. Now I'm not sure that I love the fact that I have to update the read index at the bottom. But I guess that's what is going to happen now. Yeah, the actual drawing has to appear here because when we start, the read index is 0 and we do want to read that index. So the actual drawing goes here, and then we'll update the read index to like 1, for instance. And then there is this whole thing with a fix me here, and the intent of this part was simply to draw this ASCII kind of art, because it's just blocks. But the intent was just to see if the circular buffer was behaving correctly, and it seems to be. So I can remove this part. It doesn't really matter. And then I do update the read index here because it has changed over there. Okay, so we are again, I guess, in a good stage. Let's double check. I expect the tests to be passing. And I expect the waveform display to not be displaying anything anymore. And it's not displaying anything anymore. But it's not taking too much CPU, which is, I guess, is a positive result. It means that I'm able to push into the waveform display because this is pushing into the waveform display. And it's not like going crazy. My computer is not misbehaving. Everything seems to be good. It's just the drawing that is not happening. So let's commit what we have. It's kind of neat how this change was so small. Then let's do the actual drawing. Well, for this, I said that I wanted to do it off canvas. We will get to that, but not right now. We will draw in canvas on the thing that you see on the screen. Yeah, let's start with that. So now we need to sort of re-implement an algorithm that we implemented, I guess, 3 times already in the stream. The idea is that I'm going to read the samples and I will paint them on the screen. And typically I do that by looping over a bunch of samples, finding the maximum and the minimum so that I know how many samples, and I have to loop over the however many samples are necessary for one column. But let's start with something even simpler. I will just GFX, I think it's line, I forget, I will have to look it up. JS effects. Graphics, line. Okay, that's simple. But I of course will need to compute what are X and Y and X2 and Y2. Anti-aliasing I want to be enabled, but I don't think I have to pass that. I think that's the default. So one thing that I am doing in drawing is, oh, no, not in this case, because I'm in a function. One thing that I'm doing in drawing is I usually prefix and namespace the variables, but I'm not doing that here because this is a local function. This is a function with local variables. So let's just compute x, y, and let's think about it this way. Let's do the simplest thing, that we'll draw something on the screen. I will have x equals to 0 and y equals to g of x height divided by 2. So that's the midpoint. Then I am reading the circular buffer from left to right, which means that I am doing that in timely fashion. I'm doing this from past to future. I'm going in the right direction. So it means that I want to start at the left and then go to the right. And I guess I will call this the previous x and y. And then I will compute x equals something, y equals something. I will draw to previous x and y. And then I will update like that. So now the only part missing is the computation of the x and y positions. What will be the x position? I think I will do the simplest thing that can show something on the screen right now, which is to just add the width of the window divided by the size of this buffer. Whatever. And then this will be half of the height minus the sample. So I will need to read the sample, which I'm not doing right now, but I need to, and multiply it by this. Okay, whatever. I think that that will do. But I do need to get a hold of the sample. So let's do it here. The sample is equal to samples at read index. It's actually as simple as that, because a circular buffer is accessible directly, just like this. Cool trick. So that will get a hold of the sample, and then let's create local variables. Interestingly enough, the sample local variable was already declared. It was just not used. Whatever. Let's declare our local variables. And I think that that will do. I will want to have a color on this. And now there is a line, and the line is moving as I speak. So that means it's a good sign, right? It's it's moving ever so slightly. It's not moving too much though. I wonder why that would be. I can declare a debug variable here, which I can access on this view, and it is moving around. Is it reacting to when I speak? I think so. I think that the values become larger when I speak. Okay. And other than that, half of the height minus the sample times half of the height. So I guess it is what it is. This is what the waveform looks like. It is moving, but only... It's not moving enough for me. What's up with that? what if I just look at the y variable? Then, yeah, this is changing, all right. But it's not changing by much. But still, I can see that it is changing around. So, yeah, okay, I'll take it. It's probably fine. Okay, but so far, what we have been doing is we are drawing essentially the circular buffer, or the length of the circular buffer. Not really the length of the circular buffer. We are drawing... What are we drawing? Oh, we are only drawing the beginning of the circular buffer, and we are going off screen. That's not really what I wanted, but maybe I will commit this before I move on. Yeah, all right, we'll do this incrementally, step by step. It's kind of a complicated piece of code to write, at least this for me. So now let's, instead of trying to draw the whole circular buffer, which is this part, how about we just draw the part of the screen that we want to be at? So how do we even reason about this? Well, I have a read index. The read index is always between including 0 and not including samples length. Because then we use the circular counter to wrap this back up. When it gets to sample length, it gets back to 0. It circles back to 0. Let's make sure that this is the case. The circular buffer is wrapping with a maximum of this, which is that, and then wrap maximum yeah, it's doing that. It's checking. If it's less than, return the value. Otherwise, wrap it around. Great. So this read index is between 0 and samples length. And we want to write to the screen in the section that corresponds to this. So my X position on the screen, which is left to right, that is, let's say, between 0, including, and let's say that it's not including, just to make things easier, GFX width. Now this is only a single pixel, so maybe I could write there, I'm not really sure. But now I have to try it. Now that I said this out loud, I will have to try it. So let's go into the waveform display itself, get a beautiful red color, and then GFX rect, and then the X position will be GFX W -1, the Y position can be 0, the width can be 10 pixels, the height can be GFX height. And then we see a red line just barely off screen, just at the edge of the screen. And if I change this number to be GFX width, I expect it to go off screen, and we no longer see red. Exactly, perfect. So my logic was correct. I don't want it to be an inclusive boundary. My logic here, I want this to be not inclusive. So all of this maps out fairly well. So I guess I want my X to start at read index divided by this multiplied by that. That's our position on the screen. And then I can sort of reuse this formula when computing this. because the read index will be updated, I'm computing the next position I need to be. So let's look at what this draws. I expect it to be moving left to right and drawing on the screen. And it's drawing the waveform all right. It seems to be working. And that is exactly what I want, because now if I persist this drawing on the screen, it will be the waveform thing. So it's drawing the waveform, but it's moving across so fast that we can barely see it. And we do want to persist previous drawings before updating to the newer drawings. So let's commit what we have, because I think that we are making progress. And what is the CPU use? It seems to be okay. Everything is drawing smoothly. The CPU use seems to be in check. So great news. Next, let's do the part where we persist the drawing. As I mentioned in the beginning of the stream, I tested this, and as far as I can tell, if you draw to the screen, there is no way to get that back. But if you draw to an off-screen canvas, you can get that back. So let's do off-screen drawing. We are doing drawing over here in the while loop. So let's change our GFX destination to be 0. So on the screen here is destination -1. Any destination between 0 and I guess like 1024 or something like that is off-screen drawing. In fact, when I do just that, you'll be able to see that it's no longer drawing on the screen. See, nothing on the screen anymore. And then we will do the drawing just the same. It's important to set the GFX, what is it called? Image dimensions. It's not get, it's set. It's important to set this, and there is a gotcha. When you set the image dimensions, the contents of the image will be undefined, but as far as the width and the height are the same every time, it seems to be okay. So we'll do that. And our image is image 0. I guess I can use just this variable here. The width can be the width of the screen. The height can be the height of the screen. So I'm ready to draw on this. This is actually drawing now. This call is important. If you don't set the size, it doesn't actually work. I guess it doesn't allocate the memory necessary to do that drawing. But now it is allocating the memory. It's just we still don't see that. So in this while loop, when we say GFX line, now it's drawing into this destination image. So all we got to do is, after all the drawing has happened, we say that the destination is back to being the screen, and then we blit, and blit has a bunch of parameters. So we'll blit what is the source? It is 0, this guy. What is the scale? 1. What is the rotation? None. What is the source? X and Y and width and height? Well, it is just 0 and 0, and GFX width, GFX height. What is the destination? X and Y, width and height, the same. And then there are some rotation offsets that I don't really need because I'm not rotating anything. So now we should be back to seeing the thing we saw before, where it draws across the screen. Oh, and it is already drawing on top of the screen and updating and not erasing anything. That's progress. Let's commit this. Let's make more progress. Another thing that we want is to erase what was there before. So we can do that with setting the paint color to black. Then we can draw a rectangle from position 0 and no, not 0, from position X, Y0, and then what is the width? 1, and what is the height? GFX height. So this should draw a black rectangle before drawing the line. Or maybe it should be previous X. Yeah, I think it should be previous X. And then this width of 1, it could be the width of this. I think that, strictly speaking, this is more correct. So let's see what that looks like. Okay, so it's still not drawing any black rectangles. Maybe the black rectangles are small. I don't know what these glitches are at the bottom. But it doesn't seem to be doing anything. So let's first check that I got the parameters right. Okay, fills a rectangle with XY, width, and height. So far that makes sense. X and Y, width, let's do it like this to make sure that it is at least drawing 1 pixel, and the height of the window. That seems to make sense. Let's try again. Okay, it is drawing and it seems to be forgetting stuff from the past. But it's still kind of not looking as it should, because it is skipping. It seems to be skipping some parts, or maybe just the rectangle of 1 is too aggressive and it is erasing stuff. Yeah, and we are doing this on every sample. We don't need to, because we know what this difference should be. Not quite. It's kind of annoying because it could wrap around. So how about we change this up here? And we already have previous X. We just erase the next 20 pixels. What does that look like? We can see black rectangles being drawn and the waveform is all crazy. It seems to have some holes in there and some parts are not erasing. Let's return to this. Oh, this is going to be very aggressive. It's going to just draw black. No, it's just jumping around here. Whatever, I will just commit this because it is, let's just do 1. It is erasing stuff from the past. At least it's not accumulating everything on top of what was already there. But let's think about something else. Right now, this is sort of short-lived. This is... Oh, Bo is here. Hi, Bo. Look at what we have. It's drawing something on the screen using that new idea of having a circular buffer to communicate between the auto and the UI thread, and drawing off canvas and accumulating stuff. So we are making progress. I hope you enjoyed this. Just lurking while I'm fixing typeface issues on my MacBook. Tell me all about it, because I love typography. Are you designing a typeface and you're solving typeface issues? Or is your macOS not rendering typefaces correctly? Tell me all about it. I love typography. Right, so another thing that we can do is there is nothing that tells us that we have to draw on this. There's nothing that tells us that this off-canvas thing has to be the size of our screen. In fact, I suppose that if I resize this, oh, it kind of looks glitchy anyway, but I was expecting it to look more glitchy as I resize it. So we need to fix the size of this image, and it needs to be independent of the canvas in which we actually draw. Oh, you're saying conflicting typefaces. I think I know what you mean. If you install multiple typefaces with the same name, they may be like, no, this font must be downloaded, so that's not the issue. But they appear here with an exclamation mark. I don't think I have any case of that. That's good. It's true that I manage all my typefaces using Homebrew. In case you have not heard of this, it's kind of nice. Homebrew Fonts. It is restricted, of course, to free open source fonts, but it manages everything for you. And you can install non-free, non-open source fonts, but you will have to write the installer yourself. Though the installer is not too complicated to write. It boils down to something like this, a Ruby file that essentially looks like just a declaration. So using this, you could install your proprietary fonts as well. And there are things like Typekit by Adobe, but you know all this already. Right, so let's set the image dimensions independent of the screen size. And there is something kind of interesting about this. Here it says that the width and height must be up to 2048. On the REAPER editor, you can see some help up top. And then this help here says that the index needs to be between 0 and 1024, which is already not matching what we see here, and that the width and height must be between 0 and 8000, and this says 2000. So I am betting that this is outdated, and I should trust these values instead. And that's what I will do. I will trust this value here of 8000, and I will not use 8192 because that's just too crazy, but I will go with 8000. I bet that the reasoning is the same as my reasoning before when I got the number 8000. It's just an 8K display. So they probably updated the value here. They did not update the value there. So let's go with the value that we actually wanted to begin with, which is, what is the width and the height? It is just 8000 by 8000. And then in several places where I have the width and the height, I will want to change that. So let's see. I guess in all places, except when I am bleeding. So I am hard coding this 8000. I will extract a variable at some point, but not right now. Right, so the effect that this has is that I will be drawing over more stuff off canvas, and then when putting it on the screen, I will squeeze it to fit on the screen. So I expect the visual effect of this change to be this will not wrap around so quickly. Okay, it does seem to be not wrapping around so quickly, but it also seems to be very slow now. And also the line is almost invisible, probably because of all the erasing that is also happening. So what if, instead of drawing a line, a quick hack to fix another quick hack? What if instead of drawing a line, we draw a rectangle? So I will need just X and Y and just some numbers here like 4 and 4. And then I don't really need this previous X situation here. Yeah, I don't think I need this at all. Let's check this. Okay, the line doesn't look as faint, but it still looks weird, very faint. How about we don't erase stuff for a moment, just to see what it looks like. Okay, it is accumulating on the screen, and it's sort of like, it looks nice, but it moves around more slowly, I think, because the canvas now has 8,000 pixels. And more importantly, it shouldn't glitch as I move it, and it doesn't. It resizes all right, and it does not glitch. Now, maybe a reason why this line is so faint is that I'm drawing on a much bigger canvas and sort of resizing it down. I like the way this looks, but the solution for this is just to make the rectangle a bit bigger for now. At least it's a hack that should work. Okay, it's a bit bigger now. And how about we erase what was there before? Okay, things are slow again, so that erasing must not be making things any better. Yikes. I wonder if the size of the rectangle that I draw affects the performance, because previously we saw that when I zoomed into the waveform, it was making things slower. Shouldn't be the case, but still has me wondering. Right, so I will take this off. I will read what you all wrote on the chat. Okay, you're gonna check it out. Yeah, it's what I use to install most of my software, except for the VSTs. And then I will sign off. Tomorrow I am taking the day off. But on Friday, I will be over at IDDQD Sound, and we will continue working on my song. You need to shower, but you don't need to shower as often as you do. But you probably don't need to shower. I mean, you may need to shower even more often. Who am I to say? So see you on Friday over at IDDQD Sound, and thanks for being here. Thanks for watching this. I hope you find this entertaining and illuminating. See you Friday.